All right, we're going to be looking at the pre-lab for the fatty acid methyl ester lab. And what we're going to do is we're going to take a class of compounds, lipids, that are known as triglycerides or triacylglycerols. And I just saw that this has got a typo. There should be no Y there. All right, and a triglyceride is composed of a 3-carbon backbone, this 3-carbon backbone right here, that contains 3 hydroxy groups that's connected to what we call 3 fatty acid esters. So I'm going to just redraw this a slightly different way. So here's our glycerol backbone, and each one of these is connected to a long chain carboxylic acids. And those long chain carboxylic acids are called fatty acids. And these fatty acids are an even number of carbons, and they can either contain alkenes or not. If they contain alkenes, they're called unsaturated. And if they contain, say, 1 double bond, then that's called monounsaturated. And if they contain more than 1 double bond, then they're considered to be polyunsaturated. And if they, like I said, if they have no alkenes, then they're considered saturated. So in this lab, we're going to take this triglyceride and we're going to treat it with methoxide ion in excess. And when we do that, we're going to cleave the ester into its components. And so if I wanted to put in real examples here, let's just say, since we don't know the identity of our fatty acids, let's say that we're going to start with palmitic acid as our fatty acids. And palmitic acids has got 16 carbons total. So I'm going to need 14 of these methylene groups to get a 16 carbons total. So if I go and I take this triglyceride and I treat it with excess sodium methoxide, I'm going to break apart in excess methanol. I'm going to break it apart and I'm going to get my glycerol molecule, and then I'm going to get 3 of these fatty acids. In this case, they would all be the same. They'd all be palmitic acid. Okay, so our job is going to be look at different types of oils and fats, and to see if we can determine how many double bonds are present, or the degree of unsaturation in the oils that we're using, because polyunsaturated fatty acids are actually good for us. They're not stored in the body as easily as saturated fatty acids. They get broken down more readily, and so it's better for you to eat the polyunsaturated than saturated fats found in, say, coconut oil or lard or butter. All right, so what we're going to do is we're going to try to determine the degree of unsaturation in our fatty acids. Now, how we're going to do this is we're going to use proton NMR. Now, the NMR for a fatty acid can be complex because we've got all these methylene groups and they can all lump together. So what we're going to do is we're just going to focus on 2 areas. We're going to focus on the area where we'd expect to see a double bond. So we expect to see alkenes between 5 and 6. And so here we have our alkene hydrogens coming. And then if we have a methyl next to an oxygen, we'd expect it to come around 4 and be a singlet. So that's where we'd expect to see those hydrogens as well in the proton NMR. So we're just going to focus on those 2 peaks. And what we're going to do is we're going to integrate them. Now, if you have a cis double bond in the molecule, and you have, or if you have any double bond, you're always going to have 2 hydrogens per double bond, right? And if you have a methoxy group, you're always going to have 3 hydrogens for that. So they don't have a 1-to-1 peak, 1-to-1 hydrogen ratio. So we've got to make it a 1-to-1 hydrogen ratio. So we're going to have to take whatever this integrates to, and we're going to have to divide it by 2. And we're going to have to take whatever this integrates to and divide it by 3 so that we can get that 1-to-1 relationship. All right, so that's why we need to divide the alkene integration of the double bond by 2 and the methoxy region by 3. And then what we're going to get from that is going to be the ratio of the double bonds per ester can be calculated. So for example, if I had this monounsaturated fatty acid, like in the example here, when it integrates, I'm going to have 2 hydrogens. So this peak here, I'm going to clean it up a little so I can see what's going to go on here. You know, this would integrate to 2, whereas this guy would integrate to 3. So if I take this and I divide it by 2, I'm going to get 1. I take this and I divide it by 3, I'm going to get 1. So then I can know, oh, I've got 1 of my double bonds per fatty acids for here. All right, going on to this page. So what we need to do is we're going to take your fat or your oil and you're going to reflux it. We're doing a lot of refluxing. And use your drying tube. And we're going to add 1 milliliter of the freshly prepared sodium methoxide solution to the round bottom flask, and we're going to reflux it for about 30 minutes. We're going to cool it to room temperature. We're going to add 20 mils of deionized water, and then we're going to put it into our SEP funnel. Then we're going to add some ether. The ether layer is less dense than water, okay? And we're going to shake them up and let them separate, and we're going to drain out the water and we're going to drain out the ether, and then we're going to pour back in the water and we're going to add some more ether. We're going to shake it up again. We're going to remove the ether. We're going to combine the ether extracts, and then we're going to wash those ether layers twice with sodium bicarbonate to get rid of any extra acids. So make sure you are venting frequently, or you're going to blow the top of your separatory funnel, so be careful. Then you're going to give it a quick wash with water, and then a quick wash with brine to dry it roughly, and then dry it better with a better drying reagent, and then use gravity filter to remove that solid. You're going to transfer that ether layer into a Erlenmeyer flask, and then we're going to remove the solvent by reduced pressure. So remember, we gently heat our flask here. We have it hooked up to another flask that we have in an ice bath, and then that's going to the vacuum source. So this is in an ice bath so that we can collect that ether. All right. Then for analysis, we're going to get our yield. Once again, we don't know which fatty acids that we have for sure, so we're going to pretend that we have the 3 palmitic acids, and get your percent yield, and then you're going to have your compound that you worked with in delta, and you're going to work up the ratio of the double bonds to the methoxy groups to find the number of double bonds per 1 fatty acid residue. And then I believe there are 4 different oils and fats offered in the lab, so then you got to work with 3 other people to get the information for the other 3. So your results section should cover all the lipids that are present in the lab, and then you're going to discuss the type of fatty acids that are present in these different lipids. All right. Now for the final report, what you're going to do is you're going to give me a section that has the 4 following sections. It's going to have calculations, results, discussions, and exercises. Make sure your calculations show how you've got the number of degrees of unsaturation per fatty acid residue in your triglyceride, and then make sure you talk about the percent yields. And then working with partners, compare the different fats and oils as the result of the experiment, and elaborate on the implications, perhaps for your diet, for those discoveries. Now, each student will submit an individual lab report, okay? You're going to draw on the data for everybody, but each person is going to turn in their own individual lab report. All right, so that will be it for the FAME lab. Let me know if you have any questions. So once again, we have a pre-lab worksheet. Make sure that you get that pre-lab worksheet, that you do those 3 quick problems, and you turn those in before you come to class, the lab. And we also have the handout for the actual lab that has the experimentals and all that, and the actual exercises or questions at the end. All right, hang in there. Let me know if you have any questions. Take care.